We are now going back and kind of looking at solving right triangles. We're looking at applications involving right triangle. So a lot of this section is stuff that we've done in the past. The thing that you might see that's a little different is on direction. So we've talked about before angle of elevation. So if we were looking at the angle of elevation, recall that was looking at the horizontal line and then going up that angle. So if it said the angle of elevation of 40 degrees, I know I'm looking at the horizontal line elevation, so I'm going up 40 degrees. We talked about angle of depression. Angle of depression. That is again starting at the horizontal line. So it said the angle of depression of 60 degrees. I know I would start at the horizontal and I would go downward 60 degrees. So that is some terminology they may use for direction, but they also might use, they will either start with north or south, give you some angle, and then end with either east or west. So for instance, if it said north 35 degrees west. Well, think about your compass, right? You have north on top, south on the bottom, west on the left, east on the right. And so this is telling me I'm starting on the north. So I'm starting at that vertical line and I'm heading 35 degrees towards the west. And so this would be a bearing of north 35 degrees west. What if it said south 100 degrees east? So in this case, again, I'm starting at the vertical line, but I'm on the south and I'm going east. So heading east 100 degrees. So that would be about here. The next type of direction that you might see is where they just say we are heading on a bearing of a number. So if it says a bearing and it doesn't give us that northwest or southeast, we want to always start on the vertical line and we always want to go clockwise. So a little different than what we've been doing. We a lot of times started at the standard position, that horizontal line, and we went counterclockwise. So bearing. So if it said a bearing of 150 degrees, start at the north, go clockwise. So starting at the north, going clockwise 150 degrees. So about right here. Okay, so now we've got some terminology that we may be using when we're looking at some of these applications. Before we jump into an application, let's just look at a right triangle. Given information about that right triangle, we want to find what they're asking. So let me pull up an example. So the problem in front of us, we have little b. So remember little b or little letters, those were our side. And those were across from the capital letter, which denoted the angle. So we have little b equals 4 and capital B is equal to 10 degrees. We're given that this is a right triangle and we want to find sides A, C, and angle A. So let's create a right triangle. And so we're given that angle B is 10 degrees. And so if that is 10 degrees, I know that opposite of that 10 degrees is a side, which is length 4. So we want to find side A, angle A, and side C. Well, we know that angle A plus angle B, that has to sum to 90 degrees because this is a right triangle. And we know that the sum of all the angles in a right triangle equals 180 degrees. And so if I have angle B is 10 degrees, I can say that angle A is 90 degrees minus 10, or angle A is equal to 80 degrees. Okay, so now let's just use angle, the 10 degrees, the angle B. And so we want to find adjacent side and we need to find the hypotenuse. So let's look at the adjacent side. So which trig function? We know the opposite and we want the adjacent. So you're thinking about which trig function uses opposite and adjacent, and that is tangent. So let's write this. This is tangent of our 10 degrees. This is equal to the opposite, which was 4, all over the adjacent, which is A, which we're trying to find. So we can multiply both sides of our equation by A. So we have A tangent 10 degrees is equal to 4. And then A is equal to, we can divide both sides by tangent of 10 degrees. So let's plug this into the calculator. Make sure when you're plugging this into the calculator that you're using degree mode and not radian mode. So looking at this, we have 4 divided by tangent of 10 degrees. And so that gives me approximately 22.7. So now we just need to find out what side C is. And we can use the Pythagorean theorem, or we can use our trig ratios. If I was using my trig ratios, I would use the side that we were given because we rounded A. So maybe let's just do our trig ratios. And so from angle 10, I have opposite and I want hypotenuse. And so that tells me I'm going to be using my sine. So sine of 10 degrees. This is equal to the opposite, which is 4, all over my hypotenuse, which is C. So if we multiply both sides of our equation by C, we have C sine of 10 degrees is equal to 4. Get C by itself, we can divide both sides by sine 10. And so C is equal to 4 divided by sine of 10 degrees. Plugging that in the calculator, we get this is approximately 23 degrees. Not degrees. If I had units, I would use the units, but they didn't give me any units like inches or feet. Okay, so given information about a right triangle, you should be able to find the remaining sides and remaining angles that were not given. So we've done a lot of that before at the beginning of the semester. And then the rest of this section goes through applications. So let's pull up some application problems and do a couple of application right triangle problems. Okay, so the example in front of us says from the top of a 200-foot lighthouse, the angle of depression to a ship on the ocean is 23 degrees. So how far is the ship from the base of the lighthouse? So sometimes writing or making pictures is helpful. And so we have some lighthouse here. We know that that length of the lighthouse is 200 feet, or height of that lighthouse. So it says from the top of the lighthouse, an angle of depression. So we have a horizontal line and we're going to do 23 degrees. Angle of depression is down. So from that 23 degrees, I see the ship. And they want to know what is that distance to the base of that right triangle, of that lighthouse. So we want to find this distance in here. Well, because we know that the angle of depression is 23 degrees, we can find the angle inside of our triangle. We know that from that horizontal line to our vertical line, that should sum up to 90 degrees. Well, 23 degrees. So we have that angle in here is 90 degrees minus 23 degrees. Which gives us 67 degrees. Okay, so we know that that is 67 degrees, and we know that the adjacent side of this 67 degrees angle is 200 feet, and we want to know what the opposite side is, which is called x. So figure out which trig function you're going to use. We want to know opposite, and we have adjacent. And so tangent is what we should use. So tangent of 67 degrees is equal to the opposite, which is x, all over the adjacent side, which is 200. So if we multiply both sides by 200, we get x is equal to 200 tangent of 67 degrees. So x here is equal to 200 tangent 67 degrees. Make sure you're in terms of degrees, and we get approximately 471. And I'm just going to round. It was 0.1, and that one would keep that one the same in the ones position. And so approximately 471 feet away from the boat and the base of the lighthouse. So looking at our next example, we have a builder wishes to construct a ramp 24 feet long that rises to a height of 5 feet above the ground. Find the angle of elevation of the ramp. Okay, so we're building a ramp. That ramp is 24 feet. We know that the height of that ramp is 5 feet. And we're trying to find the angle of elevation. So from the horizontal up to the ramp, we're trying to find what angle that is. So looking at this, I have my opposite side and I know my hypotenuse. And so that tells me I'm going to be using sine. So I have sine of angle A. This is equal to opposite, which is 5, all over hypotenuse, which is 24. So I want to figure out what A is. I don't know what angle of sine would give me back 5 over 24. And so I'm going to take the sine inverse of both sides of my equation. I did that so because I know that a function and its inverse, the composition undoes itself. And so sine inverse of sine A is just A, is equal to sine inverse of 5 over 24. So if we plug this in the calculator, sine inverse of 5 divided by 24. This gives me approximately 12 degrees. So the angle of elevation of the ramp is 12 degrees. So the next example in front of us, we have a plane that leaves the airport flying at 375 miles per hour and follows a course of a bearing of south 47 degrees west. After 2 hours, how far south and how far west is the plane from the airport? Okay, so we have some airport, we have some plane, and it tells us that they are flying at a course of south 47 degrees west. So I tend to like to make a cross there. And I am starting at the south and I'm heading west. I might need to go over here more. So starting at the south, vertical line at the south and heading 47 degrees to the west. So that's about right here. So like the origin is where the plane is starting at the airport. And they're heading this direction for 2 hours at 375 miles per hour. We'll recall that distance is equal to rate times time. So we can figure out what our distance is. We have 375 miles per hour times 2. So if we did this, that would be the distance is equal to 750 miles. So after 2 hours, we want to know how far south. So we know this line here. Did they fly? And how far west did they fly? Maybe call this X. Let's call this Y. So where we're given here, sometimes we need to do a little more math to find our angles, but our picture shows that our angle right here is 47 degrees. So I have my angle, I know my hypotenuse, and I want to find my opposite side. So let's find X first, the opposite side of 47 degrees. So opposite hypotenuse, that tells me to use sine. So I have sine of 47 degrees is equal to the opposite side, which is X, all over the hypotenuse, which is 750 miles. Multiply both sides by 750. So 750 sine of 47 degrees. This is equal to what x is. So that gets me approximately 548 and 5/10 of a mile. Okay, so now we want to find the adjacent side. And so our adjacent side, I would use the things and information we're given, not what we found. So I want to find my adjacent and I have my hypotenuse. So that tells me I'm going to want to use cosine. So cosine of 47 degrees is equal to the adjacent side, which we called y, all over our hypotenuse, which we were given was 700, or found was 750 miles. So multiplying both sides by 750, we get y is 750 cosine of 47 degrees. So plugging that into the calculator. We get that that's approximately 511 and 5/10 of a mile. So where that plane is after 2 hours going 375 miles per hour, they are 511.5 miles south of the airport and 548.5 miles west of the airport. Okay, so looking at the next example, we have a ship set sails from a shore which runs due north and south. The ship sails 150 miles with a bearing of north 22 degrees, 30 minutes east. How far is a ship from the shoreline? So I notice that I have degrees and minutes, and I want to change my minutes into decimal degrees. And so recall that 60 minutes was equal to 1 degree. And I want my minutes to cancel. So another way to write one is the same thing as 1 degree over 60 minutes. So let's looking at this 30 minutes times 1, and I'm going to write that 1 as 1 degree all over 60 minutes. So I notice that reduces 30 minutes goes into 60 minutes. That would be 2 times. So we have 1 over 2 degrees, which is 0.5 degrees. So they're heading at a north 22.5 degrees east. So starting point on the north line going east, 22.5 degrees. Let's go back and kind of reread. A ship set sail from a shore which runs due north and due south. Okay, so here is our shoreline, north and south. The ship sails 150 miles. Ship is going 150 miles And we want to know after 150 miles, how far are they from the shoreline? So let's draw a line to the shore. And so this is a right triangle. And we're trying to find this distance. Just call it X. And so looking at the angle I know, 22.5 degrees, I want to find the opposite, and I have my hypotenuse. So opposite, hypotenuse, that tells me to use sine. So I have sine of 22.5 degrees is equal to the opposite, which is X, all over hypotenuse, which is 150. So X equals 150 sine of 22.5 degrees. So 150 sine of 22.5 degrees. So that gives us approximately 57.4 miles away from the shore. So these are similar to, again, what we've done in the past. So hopefully this is a nice reprieve before we jump into some new material next week. Next week, we're going to start looking at triangles, which are not right triangles, and learning some laws to help us figure out sides and angles when it's not a right triangle.